In this video, we're going to look at the design section of the project. These are the different sections of the design stage that you're going to have to include in your project. However, each project will vary dramatically. If you're making some form of database, you're going to need to have your entity relationship diagrams. Whereas if you're making a game, this might not be necessary. So have a look at these different sections, and then we're going to have a look a bit more in depth at some of them. This is the mark scheme. It's 15 marks for this section, and it's split into 3 different sections: the decomposition, a description of the solution, and describing the approach to how you're going to test the solution. The first 2 parts are your design objectives and a decomposition of the problem. This should be on average around 3 to 4 pages in length. The first thing to do is to rewrite your system requirements that you made for your analysis section as design objectives. Some of these statements actually might be repeated. However, the rule is that each design objective is technical and measurable. So you're thinking about each one of these and how you're going to design them. You might be thinking about the inputs, the processes, and the output of this section. Get these signed off by me. If there's one piece of advice that I could give you, is that show these to me first, because these will impact the rest of your design. The next part you should be doing is producing a top-down design. This should give you a decomposition, and there are lots of examples of this available. For each section of your decomposed diagram, you then need to be explaining what this part is and how this is going to split it down to make it easier to solve. There's more help for you on pages 38 to 41 of the book, and I suggest reading this section before you start. Now, in the top mark band, this is the marking for this section. You've broken the problem down systematically into a series of smaller problems. So you have your top-down design, and each of those sections you've explained and justified why that's going to be, so like a decomposition, why that's going to be an element of your project. So you're decomposing and justifying that solution, thinking about computational solutions in each section. It also goes on to the second bullet point, defining in detail the structure of the solution to be developed. Have a look at some of the projects, the example projects, to have a look at how they've tackled this solution. In the next section, you're describing the solution, the system design, the interface design, and the data design. So this is the middle section of that mark band that we talked about near the start. This should be between 10 to 20 pages in length and should be detailed. The first thing you need to do is have a detailed structure of the solution to be developed. Now this should sit separately to that top-down design that you created earlier. You need to create a series of system flowcharts or data flow diagrams, DFD diagrams, to demonstrate how data will flow around your system. Now there's many ways that you can do this, but again I suggest looking at some examples to show how this has been done. If your program actually has various windows, you could create a menu flow diagram if that's acceptable, or it could be a set of wireframe designs. You're going to talk about any hardware and software limitations that are associated with your system. Things that are outside of the scope that you're not going to be creating, or which might cause problems during the design. You also need to describe and justify any usability features. So you're going to be producing interface mock-up designs to show the different screens, your user interface designs, highlighting the methods of inputs, how you're going to collect data, the outputs, interface mock-ups as well. What is that going to look like? And when you're doing this, you need to be thinking about inputs and outputs. Again, show these to me at every stage of the way so that I can check that you are on the right track. The final section is to identify and justify your variables, the data structures and validation that you're going to be using. In some way, you're going to have to create a data dictionary. What data are you going to be using and collecting? What type of variables will these be? Think about the data structures you're going to be using and look back at our data structures. You should be using some data structures. That could be anything. It could be tuples, dictionaries, records, arrays, and you need to be justifying why you're using those. I'd have a table for your variables, and you could have separate tables for each type of data structures. This would be a good time to start talking about some of the algorithms that you might be using. Will you be using the A* algorithm? Or what kind of algorithms might you be using? Might you be using a bubble sort, or an insertion sort, or some form of searching algorithm? This is going to add a level of complexity to your project and will show a level of detail and be able to, in the next section, allow you to access the higher marks. If you're designing a database, you need to make sure you're designing the tables, their relationships, and any normalization to third normal form that you've actually created. Now, because all your projects are significantly different, you're going to have to read different pages in the book for this section. If you're doing databases, read pages 49 to 52. Remember that you're actually going to have entity relationship diagrams in there, and you're also going to have to be thinking all about normalization and the structure of your tables. If you're using object-oriented programming, and you shouldn't shy away from this just because it's challenging, because you could get some higher marks on this, you should be reading pages 42 to 48 of the book. If you're making a game, it's likely you will be using object-oriented programming, so make sure that you read these pages carefully. In your project, I am expecting to see you're using object diagrams and class diagrams to explain the different objects that you will be using in your coursework. Again, here's the mark scheme. First of all, we're describing in detail the structure of the solution. Look at the language of the next section, which is highlighted. Describing, justifying your choices made, and the usability features. How is this going to be usable for the end user? You've identified and justified key variables, data structures, and classes that you have used. Justifying and explaining any necessary validation. This is a huge section of your coursework and will really give you top grades if you do this well. This should be roughly 10 sides of A4 and is based around algorithms. Start with that top design that you made and decompose each section. Think about every major area, and you need to produce flowcharts or pseudocode algorithms for the main processes. It would also aid you if you have trace tables and dry runs for each of the key algorithms, showing how your process will work. If it's not present, you can't gain full marks for this section without your key algorithms designed and showing how they will work. For each algorithm, make sure you make detailed comments on how they meet the design requirements. So don't just do your pseudocode or flowchart, you need to explain those. Pages 53 to 56 in the book will help you with this section. Your usability features, you need to create user interface designs. Now you might have already started this, but to help you with this, please read pages 57 to 59 in the book and look at some sample projects for ideas. Here's the mark scheme for this section. Describe the solution fully using appropriate and accurate algorithms, justifying how these algorithms form a complete solution to the problem. Again, look at the language that it's using. Accurate algorithms which are justified. These need to be appropriate to your solution. The final section of your design is your test strategy. And again, this should be between 10 to 15 pages of A4. Pages 60 to 66 in your book will help you with this section. Now, there are 3 areas to our test strategy. There's our functional white box testing, which happens during development. There's our alpha black box testing, which is against the criteria post-development. And there's the beta acceptance testing, which is carried out by a sample of end users before the system is handed over to the user. So that means we need to start planning our test strategy. How are we going to test it? And it should include all of those 3 sections. So the first section, testing during development. This is iterative testing, and this is our functional white box testing. You need a subheading in your project in the design section with something along these lines. You need to look back at your top-down design, and for each section of your solution, identify how you will test each section. If you have an element in your program which receives an input from the user, show me and state the data that will you use to test it. Remember, there are 3 types of test: a normal, an extreme, and a borderline test. If we're looking at days of the week, a normal test would be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. A borderline could be Monday and Sunday, the first and last days of the week. An extreme would be something that is not a day of the week, November, and seeing what that test would do. But what you should actually be able to do from this is take this testing and actually use it to test your program. So you might want to give each test a number, so that when you get to actually doing that testing, you can actually talk about the different tests and say test 1 has been passed, or during your development it'd be really nice to say test 2, this test has not been passed. I'm now going to change my solution because my current project is not finishing this test. It is iterative, so it should be ongoing testing. Your second section is post-development testing. Now, considering the program has been finished now, you need a test plan to check the functionality of the program against your user requirements. So you need to have your user requirements open while you write this, and then make a series of tests to check whether your project is meeting those user requirements. So for each test, again, you need normal, extreme and borderline testing. This section is very important because you do have a series of marks for your testing and evaluation at the end, and if this is not correct, you won't be able to get a high score for this section. Make sure you have clear tests for each requirement. If you cannot produce tests for a requirement, then you need to change your requirements, because that means it is not a viable requirement. If you do have to do that, make sure you document that and explain why you've done that, because you've changed your requirements, because you can't test them. And that would be a fantastic level of evaluation to have in your project. The final section is acceptance testing. You need a new section for this. Considering your solution and any issues have been ironed out, how will you carry out acceptance testing? Remember, this is our beta acceptance testing, which is carried out by end users. So this could be done by creating a questionnaire. It could be that they are given the project and give you feedback. It might be a focus group. But you need to evaluate which of these systems you're going to use. Could you create the questionnaire now, which you're going to use, which you will give to the end user? How are you going to do that? Is the questionnaire going to have a tick and evaluation section? How are you going to check that it's met the requirements for the user? Because remember, it's the user's program that you created, it's their requirements, so how are you going to get them to check that it's met their requirements? Remember that pages 60 to 66 will help you with this section. So the last 2 bullet points are in the mark scheme for this testing section. Again, it's similar language. Identify and justify the test data to be used. So you've got to have real test data and that's got to be justified. It's got to be used during the iterative development of the solution. So the testing you make now will impact your iterative development. And you've identified and justified any further data to be used in the post-development phase. Now remember, I'm expecting this to be done in early December.